Hey there, class. Mr. Pusky here. Hope we're having a good day so far. We're continuing with the last section of Chapter 7, which is 7.7, and we're putting together everything we've learned about basically right triangles using Pythagorean theorem with trig ratios and solving for missing angles and stuff and missing sides. So yes, that's what we're doing today. We're going to be solving a right triangle. Basically means that all the sides and angles that are missing are kind of solved for, okay? So we have a warm-up here. It says write what each part of SOHCAHTOA stands for 3 times. So why don't you guys go ahead and do that. All right, so is sine equals opposite over hypotenuse. Ca is cosine equals adjacent over hypotenuse. And TOA equals tangent, which equals opposite over adjacent. All right. So to solve a right triangle, like we talked about, make sure you guys write that 3 times. It's really important that you memorize that. A right triangle needs to find the measure of all sides and angles. All what? Sides and angles. Very cool. All right. So we have a new type of function today, actually, or a new type of operation, I guess. So let's figure out what these are, okay? So how do we undo addition? What's the opposite of addition? Subtraction, that's right. What's the opposite of multiplication? Division. All right, you guys got those. It's a little bit trickier. What's the opposite of squaring? How do you undo x squared? Square root is the tricky one. And now we have some brand new ones here, okay? So they're called inverse trigonometric ratios, okay? And so I'm going to write them here, but it's going to be a little weird, okay? So these are called, inverse sine. So we got inverse sine, inverse cosine, and inverse tangent, okay? All right, so, and the way we write these is a little goofy, okay? I promise, it looks like it's like a negative exponent, but it's really not, okay? So it's written as sine, like basically to the -1 of theta. This is inverse sine. You can also say arc sine of theta, okay? Inverse cosine is going to be cosine to the -1, but don't say -1. I'm just kind of showing you what it looks like here. And arc cosine of theta. And the last one we have is tangent, which is inverse tangent or arc tangent of theta. Okay, so those are all valid ways to say that. But basically it undoes like a sine or cosine or tangent. It's the opposite, okay? All right, sounds good. Let's move down here. We're crossing out this garbage. So let's do an example. This actually won't be too bad. We're just going to make sure you have a calculator handy because it's going to be useful. So if we have sine of A, okay, equals 0.76, okay? How do I solve for A? What's the opposite of sine? The opposite of sine is inverse sine. So we're going to do inverse sine to both sides, okay? And literally you're just going to plug that into your calculator. And on your calculator, you should have probably tried to figure out like where sine, cosine, and tangent are. There's 3 buttons on a scientific calculator that literally just says SIN, COS, and TAN. And if you hit the second function, the little second button, and then hit second sine, here I'll write this out. If it goes second, and then sine, it'll actually it'll equal the inverse function of sine, basically the inverse sine, all right? So we should get measure angle A is approximately, if you do inverse sine of 0.76, you should get 49.5 degrees. Ta-da! Easy as that. Why don't you guys do the same thing, but we're doing we're doing cosine this time. See if you can figure it out. All right, cosine of B. So let's write that out. Cosine of B equals 0.17. The opposite of opposite of cosine is inverse cosine to both sides. So, what's happening? And we get measure angle B is going to equal, approximately, you have to round, 80.2 degrees, okay? So basically, inverse cosine is asking, cosine's asking with this angle, what's the ratio of the sides? And inverse cosine is saying, like, what angle makes this ratio, okay? It's like the opposite. All right, sounds good. Similar thing happening here. We're looking for inverse tangent. So let's do this. So for example, we have to actually set this one up here too. All right, so what was tangent? Was that SOHCAHTOA? So we got SOHCAHTOA. Okay, so tangents, let's think here. So we're looking for a measure of angle A, right? What are 16 and 20 in relation to angle A? Hopefully you said those are opposite and adjacent, right? So which ratio has opposite and adjacent? It's going to be tangent, right? So we're going to do tan of A equals what over what? What's the opposite of adjacent going to be? 16 over 20, all right? I would leave it at 16 over 20 and just plug that into your calculator. What I would do is I would write the tan button. I would write 16. I would write the division symbol, and then 20. Well, 20 is not a number, or button, but 20, and then close parentheses, and then hit equals, okay? That's kind of how I would plug into my calculator. So if we do inverse tangent to both sides, that's really bad. Inverse tangent to both sides. We're going to get measure of angle A is equal to, approximately actually, it's going to be approximately 38.7 degrees. All right, see if you can figure out measure of angle C doing a similar thing. All right, measure of angle C. So C is going to be tangent of C, right? Because we got 16 and 20 are opposite and adjacent. So we're going to do 20 over 16. We solve for tangent of C by doing inverse tangent. And so we're going to measure of angle C is approximately, this is an angle button, C, 51.3 degrees. All right, sounds good. So now we know how to use each of those functions here. Oh, we're going one step further. We're going to do sine and cosine now. Cool. So, sine. So we're looking for the measure of angle A and measure of angle C. So I'll start with angle A, all right? So we have two side lengths. We have 6 and 19. What are the relationship of, and let's write SOHCAHTOA again. What's the relationship of 6 and 19 to that angle? Hopefully you said that that was the opposite and hypotenuse. Which one has opposite and hypotenuse? Sine does. We're going to do sine of A equals 6 over 19. How do we undo sine? We do inverse sine to both sides. And we're going to get measure of angle A is approximately, and I think, sorry, I should have mentioned some of these numbers might be a little bit off for my notes, and that's okay. I think it's 18.7. Yours might say 18.4. I think what I did is I did an approximation of this fraction here, and that might throw things a little bit off. So if you got something a little bit different, just don't panic, okay? All right, last one we need to solve for C. All right, well, we have C here. So for C, what do we have for 6 and 19? That's adjacent and hypotenuse, right? So we're going to do cosine of C equals adjacent or hypotenuse, which is 6 over 19. We got to solve for for C by doing inverse cosine. So we're going to get measure of angle C is approximately 71.3, or something different that maybe you got with different calculations. Okay? All right, sounds good. Now we're going to put things all together. We're just going to do one last example here. I don't know if we're going to do the last ones. We're going to solve a right triangle, okay? Now, this is kind of tricky. Not really tricky, but it's just we have a lot of tools at our disposal now, okay? So for the top here, I want to split these. The top, if you're looking for side lengths, you're going to use trig ratios, sine, cosine, tangent, or the Pythagorean theorem. And then if you're looking for angles, you're going to use inverse trig, or you're going to do the triangle sum theorem, right? How many degrees does a triangle add up to? A triangle equals 180 degrees, right? So you could also do that, okay? So, yeah, let's go ahead and do this here. So we're solving this right triangle, which means we need to get all the side lengths and angles, okay? So we need this side right here. I'm going to call that X. I'm going to call this, let's call this Y. And let's call this Z. That's angle B, actually. That's angle B. Okay, so now for angle B, we could use inverse trig stuff happening here, but I don't really want to. What I want to do instead is how do we find angle B? Measure angle B. What's a shortcut for that? Well, we know angle B, we could either do 180 minus 90 plus 38 and subtract those two angles, which equals, what is that? Do 52 degrees. Or you could do measure of angle B equals 90 minus 38. Remember, because if this is 90, then the other two angles have to add up to 92, which also equals 52 degrees, okay? So this is 52 degrees, which I would say is a little bit easier to solve for, okay? All right, now we need to solve for x and y. So let's think this through a little bit. So for x, and I like to use the original angles and the original sides, okay? So I would, for this one, use 38 and 12.5, because if we use 52, there's a chance that we use, we made a mistake and used the wrong number. So if we have 38, we want to use 12.5 in x. Are we going to use sine, cosine, or tangent? Let me write out SOHCAHTOA one last time here. Which one? So what is 12.5 in x? Those are opposite and adjacent. So what are we going to use, sine, cosine, or tangent? We're going to use tangent of 38 equals 12.5 over x. I'm going to set up the other one too here. What about y? What would y be? So we want to use 12.5 in y, right? 12.5 in y. What would that be? That would be opposite and hypotenuse, right? So opposite and hypotenuse is going to be, oh, something's weird here. No, we're good. So opposite and hypotenuse would be sine. So we got sine of 38 equals 12.5. Oops. 12.5 over y. Okay, why don't you guys go ahead and solve those now. To solve these, we divide by 1, cross multiply, we get x times tangent of 38 equals 12.5. Divide by tangent of 38. Divide by tangent of 38. So x is approximately, for this one, I got approximately 16, it looks like. And for the blue one, put over 1, cross multiply, we got y times sine of 38 equals 12.5. Divide by sine of 38. We get y is approximately 20.3. And those are the lengths. So now we solve for all the lengths and all the angles in this triangle. So that means we solved the triangle. All right, that's all I have for you today. Thank you for watching. Have a great day, and we'll talk soon.